will bend it easily, correct? If I put the two rods apart and I brace it, I try to bend it, it's harder. Why? Because that rod is no longer bending. That rod is only taking a compression and a tension. You form an equivalent couple. That's why the section modulus increases. Right? You all get it? Huh? No. Okay. Good. Okay. Let's say for example, if you don't understand, you must let me know. Let's say I have a 1 meter diameter rod. Okay. Okay, no diameter rod, diameter square cube, diameter square, diameter square. Okay. So what is the section modulus? It will be pi over 16 d4. Correct. Then b 1 meter. Correct. That is my maximum elastic modulus. How much bending can take? Correct. What about here? If I put it as a truss, this is 5 meters. Let's say this is 5 meters apart. That means it will no longer be this value. It will be based. Oh, this is the pi. Sorry, it's 1 over 16. So it will be just based on the axial compression because they are no longer taking bending. It's only taking axial and the compression because they form an equivalent couple. That's why you see your bridge. How come the bridge every time they do it as a truss and not one member across? You know what I mean? You see your causeway, you see a lot of the bridges around. How come it's done as a truss? I don't do it as one flat road all the way across. Right? Actually, I do need the roof one. There's no, most of the time they have no roof one. But why do they do it as a truss? Why do they need 2 layers? Why? Because if you as a truss, right, then that individual member is not bending. Your bending is always the weaker strength compared to your axial. Okay? Correct? So if I put it apart, I form an equivalent couple, they no longer bend. I just need to make sure that they don't yield for an axial stiffness. Do you all understand that? Yes? Yes? I remember somebody from SMRT, right?
It feels like 2 different things. Because one is like you say one member is like one whole block, then this one become another like.
Correct. Absolutely right. Because one member that time, right, you are mobilizing the member stiffness. But if you put it apart as a truss, right, then you're mobilizing it as a system. It no longer function as a individual member. I give you another example. Maybe the truss is not a very good idea. Let's say for example, I turn it around. Let's say for example, I have, you know, like your building. Okay, or your building. I'm not sure whether you are aware. Last time we used to have this household shelter, correct? Actually, you know why it's a household shelter? Household shelter because that is the stiffest member in the entire building. That means that when let's say you have tsunami or you have bomb or anything, right? Everything will fall apart because all of them are pin joint. Only the household shelter, right, is the rigid one that connected from top to bottom. That means it stands as a prop cantilever. All your beam here is designed as a pin supported. It could be continuous at the end. Is that pin supported? Okay. So only the household shelter is the one that's rigid. So imagine if you have one household shelter, entire building only one household shelter, that's one cantilever standing, right? What is the section modulus of the entire building? It's just based on that section modulus of the household shelter, one member. Okay. Now, if I have, after that, you have things like, for example, you have, they start to change it. Nowadays, there's no household shelter. They use the staircase wall as the bomb shelter. It's the tougher one because it creates that type of Porter frame effect. So it's no longer just one member, but it creates something like this. You know, okay. Imagine last time it used to be one member that's stiffest, correct? Now if you have things like your staircase well and you have a couple of them, they form like Porter frame. Which one have a higher section modulus? This or this? This. Why? It's not because they are using the same member size, you know. It's not because they are. It's not because the section is stiffer. It's because it mobilizes the strength. So imagine when this deform, right? You deform like this, correct? Wait, wrong. It deform like this, right? So we're assuming pure bending. It deform like this. But what about this? It bends as a Porter frame, correct? It bends something like this. It bends as a Porter frame. You mobilize the global stiffness of the system. That's why it is stiffer. Huh? Yes? Correct. Same thing as here. If let's say you have a beam like this, right? it will bend like this. Correct. But if it's a truss structure, what happens? It will bend like this. Yeah. It will bend like this. Whereby then you have it braced by the diagonal brace, so it mobilizes the system stiffness as compared to a member stiffness. That's why the lowest you mobilize it, you immobilize at the system stiffness, it will always be stronger. Okay?
So example, like okay, now we're doing the con rod, right? So
wait, let me continue first. Just now you said, right, the con rod, if I want to do the con rod, if I want to do it as a, I want to do a con rod, right? You know, just now we said, if I want to do the con, if I want to do it as a single member, I can. It's exactly like this. If I'm doing I'm doing a design for a cantilever member, could I do it as one member or I do it as something like this? As a system. You can do it as one member, definitely can. But then the section modules you need will be much larger. Okay? How can you use it as a truss to apply here? Cannot. Yeah. Flip through that PDF. Flip through that PDF.
I understand this one can be truss, but okay, if you go to the first picture, the very first one, okay, this one, how do you draw as a truss?
That's a very good question. That's why it's very good. So it depends. Hey, class, listen. This is very good. This is a very good question. That's why I say, it's not everything you can do it as a solid beam or a plate system. It depends on complexity. You know what I mean? Certain things a lot of time when I do my analysis, right, it will also need to be a solid. Even though I said that if I can do, I remember I said if I can do it as a 1D, I will do it. If I can, if I cannot, then of course it can't be helped. So something like this, what do you think? It probably hard to do it as a truss structure. Okay. Not everything. Certain things you can't do it. Certain things you just need to do it as a solid law. Especially like what? Especially like something like this. You know, you can like what you say. I can model this as a rectangular block, correct? But once I need to do a chamfer like this, it got to be a solid. It can't be cut. It must be a solid if I do a chamfer like this. Okay.
So for this, we don't need to follow because based on this, we have part A to part B, so we need to design a solid with truss and beam.
Yep.
That means I'm designing 4 designs.
Yeah.
Or those. That means number one, we need to create those that with complex that can use truss to determine. Then second one is to design a beam.
Correct. Yeah, that's why I say today you all must start to think about it. You know what I mean? Huh? Hey, class, that's a very good point. Just if you look into the assignment 2, right, they will say there's 4 modules you need to do, right? Module 3, module 4, 5, and 6. Module 3, module 4, do it as a truss, do it as a beam. Module 5, do it as a 2D solid. Module 6 as a solid. 3D solid. Okay, as a 3D solid. So of course, you can jump straight the gun to do the 3D solid. So it saves my time. I don't need to mark your section 3, 4, 5. Then you of course will not have the mark also. You are jolly well. I'm kidding. But I tell you this is why this is necessary, because practically when we do it, right, this is actually very helpful. Most of the time, right, trying to reduce the solid, the model into something simple is always the key. It's always the key. You jump straight in any model, especially very complex model. You try to jump straight in to do it full scale. A 3D solid is never going to work. It is never going to work. If I'm the client, if my consultant do me something very complicated right at the front, I'm not going to trust it. You do not know what's inside the model at all. I will appreciate how I will normally do it. Do it something extremely simple. Start with very simple first. I do it as one single beam. Of course, you don't need to do that lah. Let's say the client, because the client will have certain amount of experience. I'll do it as a truss, you know, show that what is the bending stiffness, okay, so that you can rationalize whether this makes sense or not. So you have an expectation, like what is the load you're looking at. Let's start with the plate, you know, because I'm doing something complicated. Right now, a very good question was raised. What is the thickness that is required? If you are presenting this to your client, how can you let them know? If you start off with something, wow, with the roof, all these things, how will you let them know that this is already optimized? It's very hard. You got to start with something simple. I start with cantilever beam, show you what's the bending stress. But the bending stress, what is the section modulus, you know? Then how much stress you're going to hit. Right. How are you going to convince your client that this is optimized? Right. Sorry? Start with the truss, then followed by the beam. Okay? What?
So, beam is actually 3D, right?
Beam? No. What do you mean 3D?
I mean, because you draw the beam, right? The first one you mentioned.
Yeah.
Beam is 3D. Then what's the difference?
No, not beam. Good question. Hey, can you just speak up louder? Everybody has the same questions. Don't be worried. Most of them never ask me. Once they get to their stage, they will start asking the same question. So say, okay.
Okay, so design the conrod using beam and design the conrod using 3D, and what's the difference?
Yeah,
Because 3D
good question. The beam, right? Remember in the recorded video, we say the truss is a 1D element that have a hinge joint on both ends, correct? Whereas for the beam model, it takes me more effort to record the video. I'm very serious. It takes me an entire day until 3 a.m. in the morning. Okay. Oh my goodness, I will never do this again. I'd rather I come here to teach. I can do all this even more effort. Okay, the truss is you have a hinge joint on each end, so it doesn't take continuity. A beam is when you have continuity. Okay, if you compare, right? It's a good question. Let me just show you the difference. You see the truss, right? Truss is, that means if you have no rotation, there's a hinge at the end. Whereas for the beam, right?
But my question is, isn't the 3D element a beam as well?
Yes, but 3D element, because it is also a beam, but then how to say, let's say for example this 3D beam, right? If I want to do it as a, you know that time in assignment 1, I want to taper it. If I want to do, because it's a cantilever beam, right? If I want to do something like this.
Oh, okay.
Then I can't use the beam element, correct? I can't use the 1D element. I need to do it either as a 2D element or as a 3D element. Correct? Right. If it's going to be really a tapering beam on both, let's say, I'm not sure whether I'm going to confuse you. Let's say I want to do it like this, you know, like even the thickness is reducing. Then it really got to be a 3D element. Correct? If it's the thickness is not reducing, I can do it as a 2D element. Right? Because I just give one constant thickness. But if it's going to be reducing in both the thickness and the depth, it really got to be 3D, can't be helped already. Right. Very good question. That's why I say you need to look at it. Whether can I do it as a 2D or 3D element? And you think about it, I'm not sure whether I said it sufficiently in the recording or not. Why do I do it something as a truss? Why do we do it something as the beam? Okay. The reason is because I tell you one, doing the truss, which one is better, truss or beam? Huh? Truss. Why? Good answer, but why?
More complex.
Yeah. Why do I do truss? Because truss, I don't need to account for the bending. I do it truss. This is the only way I can do it by hand. I can calculate it by hand, you know. If I do this, I can calculate because I just need to worry about the extra box, right? Even do this by hand, you can't do it. I can't validate the question because I can't account. I cannot do moment redistribution. It's going to be a nightmare. Okay, but I do need to account for the moment. But this is simpler. Why? Because it doesn't account for the moment. Very powerful. All this reduce order model, right, is always the best. You look at the result. Is it significantly different or not? No. Answer is no. You get what I mean? So which one I'll do? I'll do this. If I can, I'll do this, and then show you the result is not significantly different, right? See the result? Is it significantly different? No, it wasn't. But you can see clearly lah. You know, this is a beam model, this is a truss model. But look at the stress. Very, 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 very insignificant difference. So if it was you, what would you do? Look at it for the truss. I can even do it at hand. Right. Okay? So that's why all this is important. But you've got to think, why can I do it as a truss? The reason is why, not necessarily true all the time. That's why most of the time, right, when I do, in actual practice, when I do this sort of thing, right, I always need to do one model to show, to demonstrate to the client. Look, I will do like this, no, to be honest. If it was me, this is something very common for me. I will do it one time to show the client in the as a verification. Look, if I do it at truss, it will compare with the beam. But my subsequent analysis will always be done in the truss. Okay? To show you that even if I reduce it, yes, everybody is concerned. It have less accuracy, but is it significant? This I can do in seconds. Right? Okay? So instead of doing one analysis, I could have done 10. I can change the section modulus, I can change the material property, I can show you the result for different section modulus, for different material, to show you that this is really optimized. That is much better, right? Correct? Rather than to give you that 1.0, let's look at the difference. Rather than give you that 1 megapascal, effectively it is 297, right? This is 294, so it's 3 megapascal difference. Rather than give you that 3 megapascal difference, I rather you spend effort to run through the different modulus. You try aluminium, try steel, try titanium, try the different section modulus, try a hollow section, try a square hollow section, you know, try a different thickness. I rather you do that. The 3 megapascal is for a 300 megapascal, normally it's a 450 megapascal, right? So it's only about 0.5% of the material use strength. Totally not worth it. I'd rather you go and try the different section modulus or different elastic modulus, right? Right? Okay, continue. Think. You all must really start to do this. And the initial part is always the most difficult part. So you really must think about it. Out of the different, what will you do? Your truss model, I'm going to get each group now to come up to draw for me. What is your truss model? What is your beam model? Just now somebody raised a good point. So you eventually need to come up with a design before you analyze it. Of course, right? So I want everybody to come up. Each group. Hey, my job here is to help you all. You all make the mistake, but you all will learn from it. So don't be afraid to make the mistake. If I'm not here, how are you all going to proceed with assignment 2? So please help me help you. Come out. Somebody. Any group? Oh, I'm just going to hump down. Somebody come out with it. Okay. Yes.
Something is the cross section of shape when I do the beam. Because it's a solid material. How can I show the strength is same?
Exactly. You can't. You don't need. You can't and you don't need. Just good question. Hey, class. A good question was asked. Can I because it's not I say we can do this to be like this, right? But then now we are saying something different. I'm not doing one member, I'm doing as truss, correct? Can I show that the truss function as well as this? Of course, no, you can't. Okay, but that's not the point. The point is I can use it as a design. That wasn't for verification, that was to do it as a design. So some of your design could be like a beam or truss model, correct? Right? Okay, but you do not need to make sure that you perform as well as 3D, no need. It's different design. I will just quickly show you something. I will take 5 minutes to show you this. This is the past year and 2 years back. Okay, so I have a hook here. Okay, this is like a canopy hook. So you have something hooking here. So you do it as just a block, just a small block. Okay, I can model this, correct? Then I just need to know if I have a cantilever force here, what is the moment here? Designed for this. This is what last year, I thought it's a good thing because it illustrates better. You know why? In this case, of course, if was you can use a beam model, answer is definitely not, right? Because I'm modeling the stress here, it's got to be a plate model, then I prescribe a thickness for that, correct? In what case do I need to turn it into a solid model? I can do it as a plate. If it's true thickness, then the plate is solid, no difference. But if I'm doing it with a chamfer inside, not a chamfer, sorry, if I'm doing a cutout inside, can I do it as a plate? Answer is no. It must be a solid. Okay? And can I check this against the plate model? Of course I can't, but it's not the point. It's to optimize the design. And sometimes this optimizing needs to be done in a solid. Okay? Okay. Can I have the first group? Which group is ready? Or you want need some more time? Can I have somebody from the first group? Who is the first group? Group 1, group 1. Who's group 1? Yeah. But you all need to do it like so you all just try it. Try it as a class.